Hello, so today continuing on Leetcode, 30-day challenge solving min-stack problem. We're going to design a stack that supports push, pop, and top and retrieve the minimum element in constant time. So we can push X, we can pop, and then we can get the top element and get the minimum element. So from getting the minimum element in constant time, that probably hints into having a heap essentially, right? And the heap we could push, we can find the element at the front and we can pop from the back, right, of the queue. And so we could just do that. So we can import heap queue, I think that's the name. And let's initialize. I think this is enough as a notation. I'll verify later the notation part, but the idea would be so a problem we have if we just use heap queue is popping is a little bit difficult. All the other methods should be really easy, I think. No, top also would be a little bit tricky. So one thing we can do is just use actually both, right? We'll get min in constant time, get a heap and then get a stack and use both at the same time. So and then and preserve both at the same time. So let's say here and then here we would want to push, and we would want to push this to the heap, right? We want to push X, and then we will want to pop though. So here we will need to also append to the stack. Here we want to append X, and then here to pop we want to pop from the stack, right? So we want to say stack.pop, right? So this is the element. That's the element. We want to remove the element from the heap queue from the heap, right? Yeah, so yeah, having both is not ideal because then we'll have to go and find it in the heap, and that's not ideal. So actually another way we can solve this is instead of having both like this, let's have a stack, a normal stack for this, and then another stack for just the minimum values. So min stack, let's call it, right? So what this would mean here is that while we will need to definitely append on the stack, and also depending on whether it's empty or not. So if it's not empty, then we want to append depending on whether it's a min or not. So let's say this is a new value, right? So we want to say I think what we want to say is if peak, right? If this is bigger than X, then we want to add X to the min stack, right? And then to pop here, we just need to pop from this stack. And I'm worried about duplicates here, but we can handle that later. So if this is equal to min stack dot peak, then we need to say so here this is actually pop. And then to get the top, well, the top is just stack dot peak, right? So we need to return it, of course. And then here we need to return the min, which is just min stack dot peak. So the only places where we may have an error, so here if is maybe this is wrong, and then this here. These are the two places where we could have made an error. What's on this? Yeah, self.stack. Let's just make sure we have these rated correctly. Yep. So there is no peak actually. It's just 0. It's just -1, right? Just the last element. So we need to again I'm not sure if the problem will ever ask us for a push when for a top or a min when the stack is empty. The problem didn't define what we should do for that case. So we still have it for this here. Actually, if we should push it if it's not if it's empty. So if not self.min stack, then we should push x, right? Sorry for the syntax errors. So it's yeah, this is a mistake. So to pop here, I should just so here when I pop, I'll get the element, right? So if I have stack, let's say stack is equal to 1, 2, 3, right? And then I do stack that pop. I get the element back, so let's call this x. Okay, looks good. Let's try to submit. So we have an error with this. Let's put this custom case here. Yep. So okay, we have looks like most of the cases are correct here between the expected and values are the same. Oh, the difference is this one here, this number here. This one is, my output is not correct there. So we don't need to do this even. Yep, this is definitely not the right thing to do here. We should keep it. Okay, so let's try here. So this actually is just get min, right? That's exactly what we are getting. What we are doing with get min. So here we can just make this shorter by saying not or that, right? So either this happens or this happens. And then here we pop, and then we can just get, this is also just get min. I don't think we'll reach here with an empty list. So maybe it's not, this is not needed, but let's leave it for now. And for the top, just give that one. Looks like maybe it's working. Let's see. Yep, it is working. Cool. So essentially the idea is to just have two stacks, one that maintains the values and one that maintains the minimums, and we push to the stack the element that when push is called, and then we check if the new element that we just pushed is smaller than the minimum one. That means it's potentially a new minimum, and so we add it to the min stack. And to pop, we just pop out of this main stack, and then if the value is the same as the min, we need to pop from the min stack, right? Because that's definitely the element that we added to the min stack. And then to get the top, we just get the top of the stack, and to get the min, we just get the top of the min stack. And that's pretty much it. This looks good.